Today we are going to, talk about two important services of a serverless platform. They are Amazon API Gateway and AWS Lambda. Amazon API Gateway and AWS Lambda, complement each other and help us achieve um, serverless front end and back end, and gives us the complete application as a whole. So basically, we'll start with Amazon API Gateway, and we will understand AWS Lambda as well. So let's understand some of the API management challenges. So some of the challenges are, maintaining multiple versions and environments. Um, when I say environment, we need to maintain development, staging, and production environments. It can be monitoring third-party developers' access, um, and giving access to those, authorization, operational burdens for traffic spikes, and also some of the management overhead, which increases over a period of time. So the whole serverless um, architecture can be seen as a microservice architecture where we build uh, components specific for a single purpose, and they are primarily connected through APIs. They are connected through HTTP or RESTful APIs, and basically these services are black box, which means that they each each of the services do not know what the other service are doing other than the API specs. So microservices pattern is growing in modern architectural patterns. So way back in 2006, S3 had somewhere around 8 microservices. Now, in 2008, it was somewhere around 235 distributed microservices. So these API, okay. So these APIs are or microservices are uh, getting um, accepted, or the microservice pattern is growing in the modern architecture. So let's understand how the Amazon API Gateway solves our API Gateway challenge, API challenges, and how it is implemented. So API Gateway is a fully managed service, which means that it takes care of provisioning the servers based on the need, and also it handles it completely manages availability, scalability, and security, and the complete management of the service. So this also hosts multiple versions and stages for your API. So stages here is a synonym for environment. So um, it handles uh, multiple environments. This also creates and distributes API keys to the developers. So you could handle throttle and monitoring of request to protect the backend. So you can also leverage signature version 4 to authorize access to these APIs. And there is also request and response data transformation and API mocking options as well. This gives you reduced latency and DDoS protection through CloudFront. So CloudFront, we can use CloudFront in front of API Gateway, and the CloudFront could give you the DDoS protection. And you can also optionally use a caching service. Um, you could generate the SDK for many different languages um, for the APIs that you have um, defined. You also have a Swagger support where you could export and import API definitions into the API gateway. So some of the API options available are HTTP APIs, RESTful APIs, and WebSocket APIs. So the HTTP, you might be wondering what's the difference between HTTP APIs and RESTful API. So in RESTful API, you would have the complete uh, CRUD operations API, and you can create a model and do JSON scheme validation and many more things. And HTTP APIs are like an individual API which is built for a specific purpose. So WebSocket API enable real-time two-way communication with your application. So how um, we establish that connection, we'll see at the later part. But basically, WebSocket connection means you would have a full duplex connection between your device and the API gateway. So this goes with serverless model, and you pay API gateway as you use. It also has auto scaling and high available. It's also highly available. So these are some of the fully managed services which can be used as building blocks. So when it comes to compute, we could use AWS Lambda, and when it comes to API proxy, we could use Amazon API Gateway. And you could also see for orchestration, uh, there is something called as API step functions, where you could manage AWS Lambda. We'll see at the we'll see step functions at the later part. So basically, these are there are a lot of fully managed services provided by AWS for different category, whether it's compute, storage, messaging, analytics, or edge computing, or even monitoring and debugging. There are some of the patterns which are used in API Gateway. So API Gateway can communicate, or it can invoke directly Lambda functions, or it could communicate with step functions, wherein step functions orchestrate the flow of the um, flow of the process, where the order of Lambda execution. And it also API Gateway can also communicate with many other services like Amazon S3 or Kinesis or DynamoDB. So let's understand why there are different patterns and why how they are communicating with the other systems. So this is a comprehensive diagram where it depicts how it communicates with different systems. So I'll explain at a very high level, then we can understand at a deeper sense. So there are basically three types of endpoints. One is edge optimized, other is regional optimized, and I'm sorry, regional endpoint and private endpoint. So edge optimized is basically will have uh, will be backed by CloudFront distribution. So CloudFront is a fully managed service. So uh, it communicates with API gateway, and edge optimized is um, edge optimized provides um, the request at the edge locations, so which would improve the latency while communicating with the API gateway. Or if you have configured for regional endpoint, or let's say you have your own CloudFront distribution, for example Fastly or any other CloudFront distribution that you already have, and you want to configure it with API gateway, then you could use regional endpoint. So regional endpoint basically have can communicate with uh, any AWS services which are part of the same region, and which means it is scoped within the AWS region, and it can also communicate with customer managed CloudFront distribution. And also, if you have any services or application which is part of the VPC, and you want a private communication channel between API gateway and the services or application within the VPC, then it's best to use private endpoint. So for any HTTPS request, which is like mobile apps or website and services, edge optimize is preferred. Or if you have your own CloudFront distribution, then regional endpoint is preferred. So Amazon API Gateway, have optional caching facility, and also each request is logged in CloudWatch at a stage level when you are using basic monitoring. And also API Gateway can communicate with um, different AWS services. So as I mentioned earlier, there are three endpoints. Edge optimize. Edge optimize are designed to help reduce client latency from anywhere on the internet. So you would have um, you know a CloudFront distribution in front of API gateway where it will have edge location nearest to the client, and um, it serves from the nearest edge location to the client. And second type is regional. It is designed to reduce latency when calls are made from the same region as the API, or you could bring your own CDN in front of the API gateway. Or if you're designing the API um, for services within the VPC, then you could use private endpoint. So you can change your endpoint anytime you want. depending on how you want to use it. So let's understand the security aspect of API gateway, how we can protect the APIs. So there are basically three different offering, that is IAM authorization, Lambda authorizer, and Cognito authorizer. So IAM authorization basically provides authentication and authorization via IAM policies and AWS credentials. Lambda authorizers uh, basically perform authentication um, with basic um, credentials, and also token based or request parameter based authentication. Lambda authorizers were previously known as custom authorizers. Cognito authorizers are basically they integrate, API gateway integrates with Cognito user pools, and they create complete managed user management system. And you could use Cognito authorizers if you have, Cognito user pool user management system already in place, or you could create one if required. So resource policies are, they can be combined with any of the three IAM authorizers for building fine-grained policies. And basically this gives you a global security around the API gateway, around the APIs that you have built. So let's understand each one of them in detail. So this requires, IAM authorization requires a request to be made to the API gateway endpoint, and that request has to be signed uh, with Amazon Signature version 4 signing process. So you need to use, your access key ID and secret keys in order to generate the base64 encoded string, and you need to pass it in the authorization header for the request. So behind the scenes, API gateway will take the signed request, pass the request, determine the user who has signed that request and who is invoking it. And if the credentials are not matched, or it's matched, uh, the call can be accepted or rejected based on the authorization or authentication process. So user need to have rules and permission prior to making API calls. So the permission or the policy has to be attached prior to making the calls, and whatever policies are attached um, to that user, um, to that role, the permission will be provided based on the policy uh, which you have configured. Signature version 4 is basically a process to add authentication information to AWS requests, and it basically, uh, consists of access key ID and secret key, and it is signed based on access key and secret key based on security credentials. So Lambda authorizers are used when you have existing user management service like an OAuth provider, or when you're handling API keys for some other clients, you would use Lambda authorization. So basically, you would provide identity information, and uh, API gateway would receive that username and password or token or any access credentials that you're providing, and it would pass it to Lambda auth function, and Lambda is responsible for performing the uh, authentication based on that. And often we use OAuth provider to perform this kind of authentication. So basically, we have seen a lot many places where API key is only used for authentication, but it's not a best practice to or send API key for authentication purpose. So API keys are specifically used to determine the usage plans and throttling of the API requests. So it is recommended not to use as a uh, authentication used for authentication process. So as you can see, you can um, as the request comes to API gateway, it goes to Lambda up functions, and it can talk to it could talk to OAuth provider, and it it would send a policy to API gateway, and that policy is evaluated. If the policy uh, is allow, then it is cached, and the request is moved forward to different Lambda or any other AWS services, else it will be returned back to the client. So here is an uh, a screenshot of how do you create authorizers, and we have a request coming from an app, and which contains user ID, um, George as a parameter, and it also contains some custom headers as well. So what you could do is you could configure to use these um, details for authorization as well. Once um, the details are used by the authorizer, and a policy is generated, and the policy should contain execute API invoke action, which basically says, and the effect allow, which basically says please allow um, to execute the API invoke. So, and it also mentions what uh, resource can be accessed here. So before we understand Cognito authorizers, let's understand what Amazon Cognito actually is. So Amazon Cognito provides authentication and authentication authorization and user management for your applications. They mainly consist of two components. One is user pool and another one is identity pool. User pools basically contains user directory that provides sign up and sign in of your app users. Identity pool enables to grant the user access to other AWS services. Basically, you can think a user pool as authentication system and identity pool as authorization system, but they don't mean the same. But um, you could take that analogy for accessing AWS services. To save user profile info, identity pool must be integrated with user pool. So these two are two separate components. You don't need to use identity pool in order to use user pool. You could just use user pool, and you can use that to sign up or sign in users using user pool. And identity pool also are used mainly for federation, and also to provide AWS credentials um, to the to the user. So this would communicate identity pool will basically communicate with Amazon STS, uh, its security token service, and provide and generates a token, um, security token, and sends back to the user when it is communicated or when the request is made. So Amazon Cognito user pool implements three different tokens. So they are identity tokens, access token, and refresh token. So identity tokens basically contains information about the user's authentication, and some basic information like name, email, and phone number. Access token actually contains the information about authorized resources, and refresh token contains the information necessary to obtain new ID token, or access token whenever they expire. So usually identity token and access token expire within an hour. So Amazon Cognito provides uh, in the diagram, as you can see, it provides user directory. It also provides hosted UI. What it means is you could send a request and it would send back a HTML page where you could enter the username and password and authenticate. It also uses the standard OAuth 2 token um, for standardization, and it also has identity federation service. So uh, Cognito user pools will be providing the these many services, and identity pool would provide the credentials and federation aspect as well. So now let's understand how Cognito user pools as authorizer work. So when a user when it signs in with Cognito, Cognito will return JWT tokens, and JWT token represents all of the claim. Claim here means the information about the user. User will include a JWT identity token in the authorization header of the request, and the request is sent to the API gateway, and API gateway will communicate with the Cognito and will authorize that request. So basically, it uses OpenID Connect, which is basically like an authentication layer on top of OAuth 2. So OIDC token is pretty standard in the industry. So um, you could read up about how the process, how the framework works by by reading the specifications of OpenID Connect. So let's understand how API call flows in Cognito. So for an unauthenticated request, it would come to API gateway. Then it would come to AWS Lambda, and Lambda handler could send the request to registrar or um, login. Then that would communicate with Cognito, and it would assume it would get a role and send back to the user. Once it is authenticated, then um, a request would contain the token, and the token is as part of the authorization header is sent in the request, and API gateway would communicate with the Cognito and authenticate that request. So in this case, whenever this is an example of pet store where for registration and login you don't need an authentication, but for getting a list of pets and getting pets and creating a pet, you need this authentication. This is a basic API flow which which has both unauthenticated request and authenticated request. So resource policies are basically what they do is they allow a denoise specific address. So these are applied API wide, and you could restrict cross account access as well, and you could allow cross account uh, access. Um, let's say in this example, we are allowing user George from a different account, and particularly for get pets, um, getting a list of pets request. As I mentioned earlier, you could enable caching, and it would be if you go to the staging menu in API Gateway, you would under stage you would get a settings link, and a settings tab. You could enable the API cache, and uh, basically these caching are for get request methods, get methods, and you could actually cache on um, at the query string parameter level as well. So enabling cache is for get methods only, and you get a configurable size from 0.5 GB to 237 GB uh, based on the based on your requirement. You could configure it, and if you enable caching, then your pricing would matter as well. So you will be charged for caching. So let's understand the usage plans that are part of API Gateway. You could create um your own usage plans to throttle, you know, uh, request per seconds limit, and you can apply quotas by API keys or stages or methods. There is also you know you could do this per day or per week or per month basis. So API key level throttling is also available. Method level throttling is configurable in state settings, and account level throttling is also possible. So you could check the usage uh, per API key as well, and there's a huge opportunity to monetize your APIs through AWS Marketplace, and for that you need to use the serverless developer portal catalog. You need to register your product in software as a service a portal, and you can sell API as software as a service. So I have attached links here to perform uh, or links to basically documentation of how it can be done. So in this picture, we can see that you could set, you could enable throttling. So I have set 100 requests per second, and I have mentioned order usage as a name for this usage plan. This is the name of the usage plan, and you could set a burst limit of 500 requests. So basically, what it means is uh, 500 is the concurrent request submission that API gateway can take. If the API gateway is getting more than 500 requests, I'm sorry, yeah, concurrent requests, then it would send 429 response saying too many request error response. So you could enable quota as well, which I have set here 10,000 requests per month. You could set it for day or week or any number and any um, for day or week you want. So A- API Gateway provides us with custom domain naming capability. So you could run API within your own DNS zone, and you could name your API, pretty much whatever you want. So for that, what you could do is you could create a hosted zone in your Route 53, and you could add a CNAME for it, CNAME record for it, and you could access it from anywhere. So basically, there are two types of custom domain creation. One is edge optimized custom domain or regional custom domain. So these are dependent on how your endpoints are. So if your endpoints are in regional endpoint, then you could set up regional custom domain, and same goes with edge optimized custom domain. So here's an um, representation of multi-region example where there is US East 1 and US West 2 region. You have different regional endpoints and different custom domain for each regional endpoints, and your client can access these custom domains based on the region that they are accessing. So API Gateway provides something called as stage variables. Basically, these are environment variables, and you could use stage variables to configure and store some of the configuration informations, and you could use these stage variables with a dollar context object. I'll be showing where we could use that in a moment. So you could, these values are accessible in Lambda function ARN field, HTTP endpoint fields, and custom authorizer function name fields, and parameter mapping fields. You could, uh, map API gateway stage variables with um, Lambda function alias, and you could manage single API configuration and Lambda function for multiple environment stages. So here is an example of how it is done. So we have my function, my first API, and we are mapping for the Lambda alias prod uh, with the uh, prod of API, my first API. So this alias can be moved to any versions of the Lambda, and um, you don't have to do anything um, whenever we are releasing a new version um, with the Lambda or with the API gateway. They are um, configured at once, and they would change based on the alias, and they are connected based on alias. Hence you could move the alias names to any new version that we have come up with. So from configuration perspective, you don't need to reconfigure whenever we are launching um, a new versions of Lambda, but the configuration for new version to the alias has to be made. So let's understand how canary deployments are made. So you could use canary deployments to basically uh, gradually roll out new APIs in API gateway. So what is canary deployment is, to understand, whenever you come up with a new versions of API, you don't want to deploy completely uh, all all of the traffic towards that new API endpoint. So what you do is you set a certain percentage of traffic to go to new stage of deployment, and you would test that, and once you're comfortable, you could increase the number of percentage towards the new stage of deployment. Then you could completely move it to you could promote it to you could promote it to a you know promote that deployment into production. So here you could see we have you first, basically what you have to do is you have to enable any stage that you have created for uh, canary deployment. Once you enable it, you could set the percentage here. As I've mentioned, you could set whatever percentage that has been deployed, and so 5% would be the new stage or new version that has been developed, and only 5% of that would be sent to that uh, new version. So you could increase the version uh, as and when you feel that it is stable enough, and you could make that 100%, or you could roll back and delete the deployment or set the percentage traffic to zero, and um, revert back the traffic to the old version. So basically, when is this useful is like when you are testing a backend API backend, and when you are migrating from on-premise to AWS um, cloud. So let's understand how what is Swagger and how it is configured. So Swagger is basically an API definition as code. So basically, you could code how the API has to be defined, and it could be part of our source code repository. and they can be used with other utilities for documentation generation and many other testing purposes as well. So this API can be imported through Swagger definitions, and it can be deployed in API Gateway. So basically, these are portable API definitions. They have, JSON or YAML language. You could import or export your API. So here is an depiction of, here's a picture, here's a screenshot of how you could export the API Swagger. So there are three different options that you have. Either you could go with Swagger or Open API 3 specifications. So you could export a vanilla version of Swagger, which comes in JSON format, or if you want an extension for your API gateway, so you could use that as well, or you could export it to the Postman, client that you have. So once you export this Swagger file, yeah, you could go to the Postman client and import that and um, make the calls, or basically API definitions are loaded into the Postman client. So you could use this independently, or you could use this as part of cloud formation template as well. So here is an code snippet of how you could use as part of SAM. So SAM ultimately gets converted to cloud formation templates. So we'll understand what SAM is in a bit, but let's see how it is configured first. So there are a Lambda function which is written, and um, you know API definition which is a reference to a different part of the code, where it says the definition is part of swagger.yml. So you would include a swagger.yml file along with this in the same directory, where the swagger.yml will contain um, API definition in YAML format. You could also configure stage names and some of the variables that you want to configure as part of the API gateway definition. So let's understand what SDK generation means and how what's the flow of SDK generation. So basically, you could generate SDK out of your API gateways. So what it means is, once the SDK can be used to communicate with the your API gateway, it will handle all the sign-in process. It will handle throttled responses. So it would marshal and unmarshal the request, and retry if configured. So all that is taken care by SDK. So let's understand how the workflow is. So first, we define API in the Swagger, or we could use Open API as well, and you deploy it in API Gateway with whatever version that you are looking for, and then you ask for SDK generation, and this could be in any language of your choice. Here I have used Node.js, and this provides SDK in a zip file, and you can wrap it up with npm module. Since I'm using Node.js, I could wrap it up with npm module. So if you're using Ruby, then you could create a gem file, gem of it, and put it in your private repo, and that repository can be shared with your client, or it will be ready to consume. So if you have older versions, that would still be accessible by um, the clients who are using that API gateway. Who are using that um, SDK. So if the client here in this example, service client v111, here this client is using older version of SDK, which points to the older version of API gateway. So uh, the older version should still be there, or it should still exist. Otherwise, the SDK won't work. So let's understand what AWS SAM means. SAM stands for Serverless Application Model, and it's basically a cloud form extension, and it is optimized for serverless. So to understand what cloud formation is infrastructure as a code service, where you write the code, and mm, the code is used to build the infrastructure. So new serverless resource types are like functions, APIs, and tables are added as part of SAM uh, definition. So it supports anything CloudFormation supports, and it has a open specification, which is Apache 2.0 basically. So it is a language, or the YAML structure, which is used commonly in industry. So it now SAM has earlier the SAM had something called as SAM local to execute your SAM infrastructure locally. Now it is renamed to SAM CLI. So SAM CLI tool for local building, it validates and tests your serverless apps locally. This basically works with Lambda functions and proxy style APIs. And response objects and function logs are available on your local machine, so you could go back and check the logs or the response objects. So this also uses open source Docker Lambda images to mimic Lambda execution environment, uh, and this would emulate timeout, memory limits, runtimes, etc. So you're whenever using SAM, these are the three, you know, which are commonly used. These are the three definitions which are commonly used. This is function definition, API gateway definition, and simple table for document DB. Sorry, DynamoDB. So how do we automate our deployment with SAM? To understand that, here's a sample code snippet. and this represents the lambda function. Serverless function represents lambda function, and um, the type API represents uh, the API path that is used to trigger this lambda function. And list tables basically says what is the type of DynamoDB tape, or what is the type of resource that it is um used. So basically, SAM using SAM CLI, you could you know package package that, and once the package is done, package is ready, you need to deploy it. When once you say SAM deploy um, with these parameters, the infrastructure or the resources are created in AWS cloud. So it contains here they have, here's another yeah, screenshot of a code snippet, how it is divided, the different sections within the code snippet. The um, first two lines actually says this is not just a regular cloud formation. This is a SAM template which needs to be transformed into cloud formation. Cloud formation syntax are different um, from the SAM template. So uh, we need to say that this is not a cloud formation, this is a SAM template. And basically here we are saying the lambda, here we are mentioning what are the um, lambda function that are going to be created, what are the policies that are there, and API gateway that we are creating, APIs that are creating in API gateway, and some of the DynamoDB resources. We have metrics and logging for API gateway as well. Basically, you have CloudWatch metrics, which are like 7 built-in metrics for API gateway, which would vary from API call count to cache hits to many other built-in metrics. So it also supports error metrics for average and percentile. It also has two kinds of logging mechanism. One is execution logging and another one is access logging. And execution logging also has the two levels, that is error and info logging. Basically, execution logging captures the method request or method body content, and they are set globally in stage, and they override per method request as well. So I'm sorry, they don't override. Method logging or can override the execution logging. So API gateway also has access logging, and this actually contains the details about who accessed your API. Like you get to know the HTTP methods, IP, user, protocols that they have used, and what time they had used, and customizable format for if you are parsing it, uh, or you are you know using it for different subsystems, or if you're pipelining these logs to be processed. So there are you could actually use a log pivot. So basically it would build metrics based on your log filters, and you could jump to the logs that that has generated those metrics by clicking on the metrics graph. It directly takes you the log where the metrics was generated, and you could export logs to S3 or Elastic Cache, then explore it with Kibana or Athena if required. So you need to enable detailed metrics if you are looking for method level metrics. By default, stage level metrics is free. So if you are looking for more granularity on a method level, then you have to enable detailed metrics, um, which costs you. So you'll be charged for enabling detailed metrics. So while monitoring, you could um, see the API latency, or you could check the API latency. Basically, you get two types of latency. One is how long the latency means how long it takes from uh, full round trip response, and integration latency and how long it takes from backend to respond. So when you subtract the latency from integration latency, the API you would get the API gateway overhead. So this overhead would contain your um, authentication process and other process that you are doing as part of API gateway. So AWS comes with AWS X-ray integration. So this what it does is it would basically tracks your request flows, and you could monitor how the requests are performing, and you could get more response status about the each request. So basically you might have to enable this, and this would insert tracking header in each HTTP calls that are made, and that would report back to X-ray service, and the details are tracked. So here there is a GIF image which actually shows how the uh, request is flowing between different services, so different APIs and functions, and how the performance or status of your responses. So earlier I mentioned something about API gateway, which has WebSocket as API option. So what it does is it provides uh, both stateful connection and stateless connection. So this is basically required when you want to communicate with the client, uh, which needs a full duplex communication. Like uh, if you if you need some notification to be uh, sent or from the server, or you need a chat, uh, if you are using a chat application, um, or some streaming dashboards, then you could use this WebSockets. So as the picture here shows, the devices and the API gateway will have a stateful connection, and the API gateway and the underlying services will have stateless connection. So the connection between your uh, devices and your API gateway are uh, tracked, and you are charged based on the connection minutes, and the message which are being transferred. So uh, though this is continuously connected, as in when there is a need, you could the API gateway would trigger the Lambda function and it would perform the action. So Lambda functions are not continuously running in this pattern. So the Lambda functions or any underlying services would be uh, it would run whenever appropriate um, request is made. So um, so to understand the API gateway, how it is structured internally, so we have method request and method and integration part. So method contains method request, method response, and integration part contains integration request and integration response. So method basically deals with the end users or the clients. Integration request or response deals with the Lambda or other underlying services. So why do we need this is we might need to transform the data at a different level. So we could transform the data at method request level or integration request level, or during integration response or method response level. So here are some of the scenarios where um, these are useful. So let's say if you want to remove unnecessary data which is sent to the API gateway, you could use this method request to filter the data and send only the required data to the API gateway. Or if the calls are made through get request, and if you want to convert that to a post request, you could do that at integration request level. And if you want to return back the XML to the interface, uh, then you could do that as well as part of your response. So let's understand some of the tips that we need to follow uh, while we are using API gateway. So tip number one is don't hard code any variables. Use any values. Use stage variables to you know replace them during it can be during Lambda function names or URLs. Here's an example of defining a Lambda name. You could say demo, and this would be basically the name of the Lambda function uh, with respect to the stage variable that we are using. So it can also be, if you're using for, this is an example of demo stage and demo prod. And if it is the stage, the environment is demo, then you would use demo Lambda function. If it is prod, you would use prod Lambda function. Here how we do the setup. So the setup would be something like you would say variable name Lambda function and stage variable dot URL, and this would be reflected here. This is a stage screen and this is a setup screen. So the tip number two is always control access to your API. So there are two control planes. There are two planes, that is data plane and control plane. So whenever we say data plane, it is basically means who can invoke your or who has the access, and who data control plane basically means who can manage your resource. So who can manage your APIs in this case? So basically in data plane we have execute API invoke is basically you are providing the invoke permission to the customers. In case of control plane, you are saying what are the developers are having the access for a different API resources. It can be get, post, delete, or put. And the third pro tip is always use versioning. Enable versioning in Lambda, but use alias to point to them. And in API Gateway, point at alias, not the versions. So while you are building an API Gateway and you want to point to the Lambda, always point to the alias, but not the versions. So even if the version changes, your gateway, you don't need to make any changes in the API Gateway. In API Gateway, use stages for environment and not the versions, basically. So try to have a separate stack for development, different environments, or you could also have a different account for a different environment as well. So let's quickly jump into AWS Lambda and what it offers. So Lambda is basically a function as a service which comes under serverless computing. So let's understand what serverless computing means. So applications are still on servers, and when we say serverless computing doesn't mean that there is no server at all. They are still on servers. All server management is done by AWS. That's what that's why serverless computing means that serverless server configurations are not done by uh, the end users or the clients who are consuming the services. So let's see some of the you know paradigms from servers to serverless. EC2 um, with EC2 you manage the server. With RDS, which is basically a managed service, you pick server configuration and AWS manages it for you. And Lambda, SQS, or S3, they are serverless, they are fully managed by AWS. Here's a AWS compute offering that is provided. So whenever you want, whenever full control about your hardware, the level of abstraction, if you want to reach till the hardware, then it's best to use EC2 instances. If you need your level of abstraction to be at a OS level, then you could use ECS, that is Elastic Container Service, where you could deploy apps on the OS and you don't need to know what are the hardware, or you don't need to communicate with the hardware, then you could use ECS service. And in some cases need not we don't need to know what the OS is, what the hardwares are, and we just need to know the runtime environment that is provided. And in such cases we could use Lambda, where we could uh, deploy our functions on the runtime APIs. So here's a AWS Lambda overview. So there is an event source which triggers the Lambda function, and Lambda function would uh, communicate with the backend services. Lambda has now uh, Lambda now provides different languages: Node.js, Python, Java, C Sharp, Go, Ruby, and Runtime API. So Ruby is actually implemented using Runtime API, and um, you could use any language using sorry any framework that you language or framework that you choose that works on Linux with the help of Runtime API. So this is a new addition which was added to the Lambda. Runtime API enables you to use any language, but it has to the language has to communicate with the runtime API using um, uh, HTTP calls and making communication with it. So with runtime API, now they have uh, there are a lot of other languages or third party support that you get. So we have support for C language. We have support uh, for Erlang, Elixir, and many other languages which are provided by third-party vendors. I don't have a link here for that, but you could check that and find out how we can configure. If you are very particular about a particular language that you want to use uh, within Lambda, then you could use it. Only criteria is basically any language which can be configured to run in Lambda, sorry, in Linux can be used to, can be used within Lambda with the help of runtime API, of course. Um, so there are some common Lambda use cases. So you could build a static websites or a complex web app as well. You could build a backend, data processing. You could build a chatbot. You could build a Alexa skill and some of the IT automation processes. So to understand the how lambdas are structured, basically any hardware would have a virtual machine, a system, a server would have a virtual machine on a physical bare box. It would have a AWS instance, and instance would have a container. The container doesn't mean a um, elastic container service here. It's just a container which provides a runtime for AWS Lambda function to exist. So let's understand some of the benefits of AWS Lambda. So AWS Lambda is stateless and they are triggered based on code execution. So basically, their code is executed based on triggers. Sorry. So what makes it easy is with the Lambda is we could perform data-driven auditing analysis or notifications, and you could build a backend services, and that could perform uh, with scaling with any number of scaling. So no servers, there are no servers to manage. You could just write your code and upload it. There is a continuous scaling with Lambda, so it automatically scales based on the request or parallel requests that are coming in. You don't pay for idle infrastructure. You pay only for the number of minutes and the CPU usage it has used. So uh, basically you run uh, your code in response to the trigger that has happened. So this would involve event driven architecture. So there are some of the sources that could integrate with Lambda. So there are data sources, there are endpoints, there are some repositories which would invoke the Lambda. There could also be event or messaging service that could trigger Lambda. It could also be time based or scheduled events which could trigger Lambda. So what is AWS Lambda? What is the using? What do you say? How do we use AWS Lambda? So basically, we bring our own code. It can be many languages mentioned here, and you could set the resource that you require. It can range from 128 MB to 3 GB, and you could integrate with different event trigger type. It could be synchronous, it could be asynchronous, it could be poll based. um, you could have a flexible authorization. Securely, you could basically uh, grant access to resources, and you could place the lambda within a VPC, and you can fine grain control over the invocation of your functions. You could also author these functions using your own IDE, and you could deploy it in the AWS cloud. But AWS also provides built-in Cloud9 IDE for you to uh, code online within AWS cloud. That is. So you could also monitor and log each request and actions that it performs. And there are you could use the programming model of threads and temporary directories, and um, you could use AWS SDKs, which are uh, built in with Python, Node.js, or C Sharp, or any languages within your function. That is. So it also provides. It is basically stateless, so you might have to store the data externally to you know um, to access the data between different functions. And here is an um, figure which depicts how it communicates with different systems. So the trigger could be from API gateway or direct HTTP invoke events, or it could be custom events, or it could be Alexa skill set in this example. It could be anything. And AWS Lambda should have a role to communicate with uh, AWS services. So let's understand how we invoke Lambda function. So there could be uh, there are three invocation models. Um, so they are synchronous invocation, where um, you wait for the function to process the event and return the response. So this is how uh, with synchronous invocation, the execution happens in a way that it will return the response immediately. With asynchronous invocation, um Lambda queues the event for the processing and returns the response. And with asynchronous invocation, Lambda handles retries and can send failed events to um, dead letter queue if you are configured to send the message to SQS, dead letter queue SQS. You could also use a poll based execution model. Basically, this is event source. You could achieve it through event source mapping. So what it does is it you can map it with some of the streaming services as well as SQS, where uh, AWS Lambda would go and for um, check for the messages or the changes in the stream uh, to um, get the function invoked, and this could happen in the messages can be retrieved in batches, or the data that can be retrieved in batches as well. So basically there are three different execution models. So these are all the services which can be used to invoke Lambda function, just captured here to for your reference. So let's understand how the function lifecycle works. So it basically, when event is fired, it would call the AWS Lambda, and AWS Lambda would check if there are any active containers available for this Lambda function. If there are no Lambda, if there are any containers which are already available, then it would create another function out of the same container, and it would uh, the new active function would use the new request to perform. But if there are no containers, then it would have to create a container, and a new function has to be you know uh, a function has to be generated, and that would communicate with the request. So basically this is a warm instance, and this would be a cold instance, and cold instance would take more time to start and communicate with the request. So packages, basically these containers, uh, what it does is it packages your code and launches a container, and it it takes time to set up the container, bootstrap it, possibly for every Lambda invocation. AWS Lambda tries to reuse the container for subsequent invocation if it is already called previously. So under reuse, any declaration remains initialized, for example, database connections and many other things. But now they have come up with uh, something called as database proxy, where you could use that for database connections. So you could use scratch space, or this is a temporary FML storage space where you could save some of the cached content if you want to. So each Lambda would get somewhere around 512 MB of scratch space. So these uh, contains background process or callbacks that not completely. So some of them which are not completed can still resume if they are part of the containers. So let's understand the anatomy of Lambda functions. So this here's an example of Lambda functions. There are handler function. So this is a handler function where the function which is invoked. This is the method which gets called, and there are two objects which are passed in. One is event object, another one is context object. So event object um, contains data when the lambda is invoked, and context object contains information about request id, log groups, and information regarding the context of the function. So uh, your lambda function typically contains different parts. So some might be dependencies, it contains configurations, some common helper functions, and it would also contain some business logic sub functions which are common across. So whenever you are building lambda, there might be a duplicacy in the code or the definition or dependencies. So every lambda, for example, in this case, for every lambda, you could have uh, SDKs or some of the DB connections and some configuration, some helper functions, some sub functions. Even if they are business logic, there can be some sub functions which can be used by many other lambdas. So these functions or these configurations should not be part of each lambda. So what they have come up with is called layers, where you could package um, all these dependencies and common functions into a part of a layer, into part of a package where these lambdas can be individual lambda can access these package, and it would be a single package, and it would communicate with required services. So basically, lambda layers are basically to easily share code. So you upload layer once and reference them within any function that you want, that you have coming up with as well. So there are new functions which are coming up, and there are old functions that you have written. All functions can access this layer. So layer can be anything. There can be dependencies. There can be some training data. There can be uh, any configuration files. It can be anything. So they promote separation of responsibilities and let developers iterate faster on writing business logic. So these logics are part of the lambda, and what it also helps is uh, your lambda function would be very small in size, and uh, you might have noticed that when the lambda package grows, uh, it would not be visible in your you know AWS lambda console. So when you create layers and when you separate the concerns and you build a separate package out of these dependencies, your Lambda core would become thin and sleek, and you could see the code within the AWS Lambda console. So basically, you put common components in a zip file and upload it to Lambda layers. These Lambda layers are immutable. Once you uh, create it, they cannot be changed. Though you can version that and you can manage the updates for it. You can reference up to 5 layers, um, of which one could be a custom runtime. So if you are building a custom runtime uh, where you are bringing your own language into the Lambda platform, then that could be one of the layers as well. The most important thing here is the order of execution of these layers matters a lot, and because Each layer is a zip file. They are all extracted in the same path, that is slash opt directory. Each layer can potentially override the previous one. That is the reason why order is very important. This approach can be used to customize the environment, and first layer can be custom runtime, and the second layer can be specific versions of the libraries that you need. So once the first layer, if you're using a custom runtime, then the first layer has to be the runtime libraries uh, which would be installed, and then the corresponding layers has to be installed in order to reference the runtime libraries. So you get the storage of nearly 75 GB, which is limited to your region, each region. So these are the folder paths that you might need to follow. So this is a standard path that you might need to use uh, while you're using dependencies. So if you're using Python, then you might have to deploy it under libraries or dependencies under Python directory. If Node.js, then under Node.js directory, and so forth. So there are concurrent executions which can happen with the Lambda function for non-stream based. That is, if you are having synchronous or asynchronous execution, then each published event is a unit of work, which means basically the number of events dictate the concurrency, the number of invocation dictates the concurrency. So concurrency is equal to number of events per second multiplied by the function duration. So here's an example. If the function duration is 3 seconds, events per second is 10, so concurrent execution can be 30. So there can be a maximum of 1000 concurrent execution limit across all your functions. So this is a soft limit. If you need more, then you might have to request the Amazon support. So for stream-based event, where the number of shards per stream is the unit of concurrency. For example, 100 shards would trigger 100 Lambda functions running concurrently. One Lambda function processes events on shard in the order that they arrive. So basically, if there are in the stream or DynamoDB stream, whatever the requests are coming in the order, the each request is addressed one after the other. And if you have concurrent execution possible, so each lambda could pick up these requests in parallel, one after the other, and can execute in parallel. But the picking or uh, polling the request or messages would become sequential, but lambda execution itself can be in parallel. So there are few notation which means this basically means the account level, and um this means the function level. So we might have to understand a little bit about throttling and error handling. So there is again different approach for stream based and non-stream based. For stream based, the error handling can take up to 7 days or till the data exists expires. And throttled event in shards are blocking. uh, Basically, if there are any any lambda which are being in still in process or in progress state. So for non-throttle shard can continue processing. So that whenever a lambda is in a process state, uh, shards would be blocked, and as and when lambdas are available, the shards are available for processing. So for non-stream based, it varies slightly. So as and when there is throttling, it would invoke 4 to 9 error response, and application whichever is calling the lambda has to handle the retries in this case. When it comes to asynchronous event type, uh, then it any failed invocation is retried twice and then discarded. But you could configure failed invocation to be sent to SQS and SNS as well. So there is a VPC support for Lambda, where Lambda by default runs inside a system managed VPC. So Lambda cannot access resources in the customer VPC. So if you want uh, Lambda to access customer VPC, then you have to explicitly configure that. Lambda by default can access internet directly, but if you configure for customer VPC, then you might have to use outbound internet access through NAT device or NAT gateway, NAT interface gateway. So um, how are these basically how are the Lambda configured in private subnet? It's basically you attach ENI uh, that has only one private address. You configure Lambda to run in private subnets. You ensure NAT instance or NAT gateway is configured for VPC so that it can make outbound internet calls, and these are required for accessing other AWS services like S3, which are sometimes accessed through internet. So you also make sure that your custom VPC has sufficient addresses available in the subnet, because um, whenever a Lambda is launched, a separate ENI has to be configured with the new Lambda that is running. So Lambda needs permission to access resources. So there are two policies. One is execution policy and function policy. So execution policy basically means who who has the access um, to execute a certain AWS functions through the Lambda. Defines basically what AWS resources or API calls that can be made from this function. And function policies are basically who can invoke um, this function, Lambda function. So basically there are execution policies and invocation policies. So you have some best practices for creating Lambdas. So some of the best practices are when it comes to memory, CPUs are proportional to memory configured. So increasing memory makes your code execute faster if and only if that a particular execution is a CPU bound, that the particular function that you are doing is directly dependent on CPU, then increasing the memory would increase the reduce the execution time. So let's say if there is a request which is sent to the outside internet and it is still waiting for the response from the outside world, it is not dependent on CPU. So at that point, you could by increasing the memory, you won't get the better performance. So timeout is basically you increase the timeout allows for longer function to run longer, and it could reduce some errors if the function is taking more time. Note that API gateway has 30-second response time, so it has to be somewhere between 0 to 29 seconds as timeout. So that is this timeout 0 to 29 seconds only matters when you are hooking up with API gateway. So you could have retries as well. So for API gateway, Lambda doesn't retry the function execution, but API gateway generated SDKs retry the throttled requests, and specifically they are if the request is throttled. So with the permission model, API gateway synchronously triggers Lambda. So you assign API gateway a resource policy to invoke the Lambda. So that is the permission model that you could have. So here is some of the ways how you could connect Lambda and API gateway or HTTP endpoints. So basically you will have every API call triggered with a Lambda function, and API is defined as a set of resource and methods. So from the API gateway concepts, basically there are resource which are API, and there are methods which are get or post or any verb. It can be any HTTP verb, and both can automatically, API gateway and Lambda can automatically scale based on the number of calls. So there are Lambda versions and alias, which we talked earlier. So you could, as and when you make updates, a new version is generated. So you could attach a alias name to the version. It can be a latest version, or it can be any different version other than the latest. So you could always roll back those version as you need, and you could use the alias for stage promotions. Here is an example of the time taken to execute a function. The purpose of this function is basically that it is calculating 1000 times all the prime numbers less than um, less than a million. So for 128 MB, it's taking somewhere around 11 seconds, but the cost would be somewhere around less than 2 cents. But when it takes when you increase the memory to 256 MB, it the time taken reduced almost to half. It is taking somewhere around 6 seconds. Again, as you increase the memory, the it is the time consumption is getting reduced, but you can see that the cost is almost the same. So if you are looking for um, time consumption, then you could increase the memory, and if you are looking for saving of cost sometimes, then you could go with uh, lesser memory. But here, if you can see that there is some, yeah, sure. Correct. Mm-hmm. Mm-hmm. So yeah, so you could see this, you know, each 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 memory increase, there is a different uh, process that happens inside. So uh, probably if you bump up this, uh, you could have a different time that is taken, but the amount of the charges that it might incur might also vary, right? So this is basically you want to experiment and know for your particular function how the charges might apply, right? So this is uh, this is the example that they have given. So uh, they are almost similar, but there are certain cases where it could cost more, and with these memory. So you might have to play with these lambdas to find out what is the optimal option for you. So basically the takeaway is, if you're using less memory, you would end up uh, you know the latency would be more. If you are using higher memory, you get a more CPU power, and you would get the response time would be less, and the cost might still be almost on the same level. So it really depends on each function, how they have designed, and sorry, each code that you're running in this function, how it is performing. So for 256 MB, it is giving this number. It's not always the same value that this is providing, right? So this is just a function which they have taken it as an example, and they have clocked this with the different timings. So for yeah, so for different functions you would get a different timings, right? So this is not something which is a constant. So for your functions, you would get a different value altogether, which might be linear also, but this is just an example. So with Lambda environment variables, you could dynamically pass a key value pair, and you could get those within the function calling process env for Node.js, or os.environ for Python. So these are very handy in when it comes to accessing the environment variables as per the stage within the code. So if you don't want to use environment variables, you could set up a systems manager, um, and you could use parameter store to find the value uh, based on the key value pair, and you could also encrypt that using KMS, and uh, retrieve the uh, well, retrieve the values from parameter store. So to orchestrate, so let's say there are not just one function, there are 10 different functions. You could use step functions to orchestrate um, your code. So in this example, there is an you know we are extracting an image, with the metadata, and this image will check the type. If it is, if it can be, if it can store this image, then another function. So task basically means a function here. So all these are functions that are being executed based on a step function which is configured. So you could also configure a parallel task um, based on certain input values. So basically, you use step functions to you know set up a workflow within your application based on your need. So you don't need a lambda to be you don't need one lambda calling another lambda and executing the process, passing the information and executing the process. Basically, uh, that is not a right or a good practice to achieve lambda to lambda invocation. So basically, this shows the coordination of Lambda, how it works. So basically, you define a JSON, how lambdas are executed, and how the step function are built. Once you write a JSON file, you can visualize and see how the step function works, and you could also execute and monitor how it is working and what all you know by passing data, by passing input, you could see what functions are invocated. Basically, the green, which are colored green, are executed here, and from start to end, how it is executed. So it basically a step function gives you a workflow architecture or a model to uh, where you could define the workflow through code, through JSON code, and you could um execute that in that workflow model, according to that workflow model. So you could also automate the development using different frameworks. So we already saw how we could use it through SAM. There are some other options like Claudia JS and Chalice. Chalice is developed by AWS. So you could use um, Node.js approach to build your infrastructure, or you could use a Python uh, based micro framework to build your infrastructure. So there are many other you know automation uh, development framework. So you could check that as well. Sparta is for Go language, I suppose. Hmm. So you have as in a service you get metrics and logging for um, Lambda, and you can call put metrics data for adding custom metrics into the CloudWatch. There are many types of monitoring services that are available, and you could use these monitoring services for any remediation patterns that you're looking for. If there are any problem with any of the you know which is notified by any of the services, then Lambda could take care of that, or you could automate the process of remediation in terms of failure in some of the uh, uh, parts of your system. So there are when you get into event-driven security architecture model, you could have uh, event-driven logs, event-driven metrics, event-driven events itself. So here is an example of AWS Lambda, which is event-driven log, and here it is event-driven event and event-driven metrics example. So this block represents the log, the metric, and the event itself. So there is also something called as serverless application repository, where there are a lot of applications which are already written and publicly published by many of developers, third party people, and also AWS. So you could use those blueprints to bring up your AWS serverless applications without even you writing any piece of code. So you could use this blueprint to generate the serverless application with the help of already provisioned, already um, configured code. So basically, this repository contains a configuration where you could choose this blueprint and spin up your own serverless application. So as how you did with API Gateway, you could also use code deploy along with Lambda to do your blue-green deployments. You could change the traffic shifting based on canary model or linear approach. So you could you could roll back based on if there are any CloudWatch metrics or alarms which are triggered as well. So to understand some of the best practices in the event-based architecture with many downstream calls, timeouts and retries are important to get it right. Beware of service throttling, because you get maximum of 1000 concurrent requests by default, and you have having no timeouts at all, and downstream APIs being down could hang your whole you know microservice. So set your maximum invocation time for Lambda function and integrate timeout per method on API gateway. So limit the number of retries and employs um, exponential backup to avoid resource exhaustion and backlog. So code must be idempotent, uh, which means that whenever you provide it with proper input or a certain set of input, same kind of response has to be achieved all the time, as many times as you give the request, unless it is not built to do so. So use synchronous execution when a response is immediately needed, or a response is needed with after executing the lambda, and use asynchronous execution when no response is needed at all, and also enable one DLQ per function. And you could externalize authorization to IAM roles whenever possible, and externalize configuration, and particularly with DynamoDB can help you with that. And also make sure that downstream system setups keeps up with lambda scaling, because whenever there are 1000 lambda functions which are running, and if there are a downstream system like a database which could not take or which if it's not able to handle concurrent requests, then there might be a problem. So you should build such a system that it could handle the downstream system should handle the scaling of Lambda. uh, I have added a few simple serverless CRUD background backend architectures. Please feel free to go through it. um, so you could see that for this example, you could see that for every API, um, HTTP verb, lambda is generated, or lambda is present, and it would communicate with its respective lambda. So I just wanted to show you this diagram because this is a media sharing application, and this could, as you can see, the lambda, when you start using lambda as a service or function as a service, it could turn out to be very complex in nature. There could be a lot of lambdas which are written, and you could get maximum of 100 1000 concurrent executions. So, and also managing these lambdas through step functions are very crucial. So be aware whenever you're building serverless applications with the help of lambdas. So I have added multi-tier architecture for serverless. Please go through this. I've just added for the reference sake. So this is just a mobile backend service which has API gateway and Lambda associated with it, and also database layers and Cognito and secret managers associated with it. There is also single page application if you are trying to build using Lambdas and API gateways, which I've added. So please go through this.